Nigerian clay deposits for use as refractory materials in metallurgical industries, a review. Abstract clay is one of the most important materials used by the metallurgical industries. The characterization of clay in order to understand its mineralogical constituents, chemical and physical properties is of significant importance. In this paper, the significance of clay as raw material used by the metallurgical industries for the production of refractory materials were reviewed. Emphasis on the estimate of Nigerian clay deposit, and its suitability for use in the metallurgical industries as refractory materials were highlighted. Several research work exploring the potentials of Nigerian clay deposits conducted by different researchers were summarized. Keywords: clay, mineralogy, refractory materials. Introduction. Clay is a natural material formed by the progressive deterioration of rocks in silicate layers containing low carbon acid and other diluted solvents with a particle size of less than 2 m, which are plastic with a content of suitable water, which shrinks on drying, expands on wetting and hardens when fired. Idojuano et al. 2016, Aching 2016, and George, 2011. Clay is composed of minerals with small particles and a complex porous structure with a high specific surface which allows a strong physical and chemical interaction with the dissolved species. Fahim, 2018, Murali et al., 2018, and Muhammad, 2017. These clay constituents have made them useful in various metallurgical applications. Oziagbe et al., 2019, Katsina et al., 2013, and Umbugadu et al., 2019, such as refractory materials, binders in the metallurgical industries. Sani et al., 2013. Clay particle size varies according to different field of studies. Guggenheim et al., 1995, and Moore et al., 1997. For this reason, ordinary microscope is insufficient to provide an in-depth knowledge of the crystal structure of clay. X-ray diffraction, X-ray fluorescence, energy dispersive X-ray analysis, differential thermal analysis, infrared spectroscopy, and electron microscopy are best employed to study the crystal structure of clay. Obage et al., 2013, and Yusuf et al., 2018. Clay is classified according to its structure, chemical composition, origin, and nature of occurrence. The difference between the types of clay is explained by the octahedral and tetrahedral arrangements of clay structure. Oziagbe et al., 2019. In general, clay comes in three main forms with similar chemical compositions and different physical properties. This includes surface clays, shale clays, and refractory clays. Okpanachi et al., 2017. The major clay mineral groups include kaolinites, vermiculites, palygurskite, mica, smectites, chlorites, and other weathered minerals. The mixture of different clays in various proportion results in the formation of clay deposits with one group or type normally being dominant. Sani et al. 2013. For this reason, Oziagbe et al., 2019, characterized Origo and Awo clay deposited in the southwestern part of Nigeria based on their mineralogical contents and chemical composition. The result obtained from the analysis proved kaolin as the dominant clay mineral while smectite occurs in small amount, which makes the clay suitable for refractory composite. Based on the nature of application, clay can be blended to achieve the required properties. Titulagenao et al., 2011. Hence a comparative study on refractory properties of dolomite using clay as additives was conducted by Oyetunji et al., 2018. The result obtained from the study was compared with imported fireclay bricks and ASTM standards for refractory grade dolomite and found the mixture to be suitable for melting metals at a temperature not exceeding 11000 C. Some estimated clay deposit in Nigeria. Each region of Nigeria is said to have a large deposit of clays. Richard et al., 2017. Research conducted by Raw Materials Research and Development Council of Nigeria, RMRDC, Nigeria is reported to have billions of tons of clay deposits that spread throughout entire states. Muhammadu, 2013. An insight research conducted by Richard et al. 2017, showed that Nigeria has an estimated reserve of bentonite clay of about 700 million metric tons. A fused town of Edo State in Nigeria is reported to contain 70 to 80 million metric tons of bentonite clay. Moreover, Bauchi and Taraba State in the northeastern state of Nigeria has an estimated reserve of barytes clay holding up to 7.5 million metric tons of baryte clay. Additionally, 4 billion reserves of clay were found to be deposited in the Niger Delta region of Nigeria. The northeastern region of Nigeria is reached with about 700 million metric tons of clay deposited that is yet to be characterized. The table below gives an estimated quantity of some of the clay minerals found in some part of Nigeria. Suitability of Nigerian clays for refractory applications. With the emergence of new trends in technology in Nigeria such as development of iron and steel industries and other related industries that uses refractory materials, clay have found several applications in various sectors of Nigerian metallurgical industries. One of the most important uses of clay is its application in the production of refractory materials. These materials are employed in metallurgical industries for furnace constructions, productions of molds for castings purposes, and smelting vessels. Oak et al. 2015. Refractory materials are composed of high melting oxides such as SiO2, Al2O3, MgO, Cr2O3, ZrO. Ibrahim et al. 2018. Their outstanding properties, which include the ability to resist heat at elevated temperature, make them suitable for use in metallurgical industries. Muhammadu, 2013. Furnace linings, kilns, reactors, and crucibles are examples of products produced from such material. Makwa et al. 2019. Furthermore, refractory materials can be classified into groups depending on the desired temperature, chemical compositions, and shape of the refractory material. Titolageneo, 2011, reported that refractory materials can either be acidic such as silica, SiO2, and zirconia, ZrO2, basic such as magnesia, MgO, and chromites, Cr2O3, or neutral refractories such as carbon graphite and alumina. Ibrahim et al. 2018, stated that refractory materials can be classified according to temperature ranges at which they are used. This include low temperature range refractory materials that can perform below 1770 C, medium temperature refractory materials which can be used in between 1770-2000 C range, and high temperature refractory materials that can perform above 2000 C. Oyetunji et al. 2018, stated that the composition of each refractory material possesses a desirable heating condition to be considered to prevent failure during a specified operation. Therefore, to ensure durability in the usage of refractory material, proper selection of such material should be considered. For instance, zirconia, silicon carbide, and graphite are employed in a severe temperature condition. Amkpa et al. 2016, Falorenzo, 2015. Physical properties such as refractoriness, thermal strength, crushing strength, and color play an important role in determining the industrial and commercial value of any refractory material and are used in quality control during the production processes. These properties differ according to the chemical composition and structure of the clay. Abdulaziz et al. 2019, Paul et al. 2011 and Ibetoy et al. 2014. Table 2 below outlines some of the important physical and thermal properties of refractory materials with their standards. Despite the plenitude amount of clay deposits available in Nigeria and the various research that have been carried out in the development of refractory products, Nigeria continues to rely on imported refractory materials for its industrial applications. Oak et al. 2015. Investigations of clay deposited in any region provide the general information required in the field of metallurgy. Omo and me, 2000. Hence, tremendous works were conducted by several researchers on clays deposited in different parts of Nigeria, ensuring that its properties compare favorably to standard requirements. most of the results obtained showed that the clay deposits possessed the required physical, mechanical, and chemical properties to be used by metallurgical industries. For instance, an investigation into the refractory properties of Jalingo clay in Taraba state of Nigeria was conducted by Adamu et al. 2018. The result showed that the clays possessed a temperature of 1300 C, which qualifies the clay for use in melting of non-ferrous materials. The performance assessment of the physical properties of Kaduna, Tagwai, and Bakoita town clay deposits as refractory for furnace lining in Niger state of Nigeria was conducted by Okpanachi et al. 2017. The result obtained was compared to standards. The clays indicated a refractoriness temperature of 1600 C, with a bulk density of 2.7 g/cm3, apparent porosity of 29.6%, linear shrinkage of 9.21%, thermal shock resistance of 17 cycle, and cold crushing strength of 310.7 kg/cm2. The parameters obtained qualify the clays for use as a good fire clay refractory and furnace lining application. Assessments of the industrial potentials of some Nigerian kaolinitic clay deposits conducted by Ovid et al. 2017 showed that the physical and chemical properties of the clays assessed were in agreement with standards. The evaluation of the chemical and mechanical properties of some Nigerian clay sample for foundry applications was carried out by Yusuf et al. 2018, and discovered that the Nigerian clays could suitably replace imported clays. Additionally, the investigation of some selected kaolin clay deposits in Nigeria for furnace lining applications was conducted by Makwa et al. 2019. Moreover, a tremendous work that studies the chemical and physical characteristics of clay samples in Sokoto state of Nigeria proved the clay satisfactory for use as furnace lining. Sani et al. 2013. Clays deposited in Niger state, Agbaja town in Kaji state, a fuse clay in south of Nigeria were investigated and found to be suitable for the production of fire clays bricks for furnace lining. Abdullahi et al. 2012, and Ilakame et al. 2016. Also, the evaluation and characterization of Gakam and Abushish clay samples in Bikwara L.G.A of Cross River State by Ovid et al. 2017, showed that the clays exhibited the required properties for production of refractory materials. Firing temperature algorithm on the physiochemical properties of Ishiago clay deposit for refractory application was investigated by Chidinma et al. 2017. The result obtained proved the clay satisfactory for the production of refractory materials. However, reference to the research works conducted by several individuals, some of the results showed that not all the clay deposits available in Nigeria possess the required properties for metallurgical activities. In order to utilize these locally sourced clays in the production of refractory materials, the physical, thermal and chemical properties have to be improved. This can be achieved by either blending two or more different clay obtained from different source or treating the clay with certain additives. Richard et al. 2017, stated that the additives can either be locally sourced from Nigeria or conventional additives. For instance, Ogunsemi et al. 2017, investigated the effect of certain additives on some selected refractory properties of anthill clay for furnace lining application. In his work, pulverized glass wastes, bentonites, clean water and 100% anthill clay were mixed at an appropriate proportion. The result obtained reveals an improvement in the properties of the anthill clay to suit the desired requirement needed for the production of refractory materials. Furthermore, an evaluation of the chemical and thermophysical properties of locally aggregated kaolin-based refractory materials was conducted by Oler et al. 2019. In this work, the chemical composition of clay sample from Ipansa town in Ondo state of Nigeria, termite hill material and processed bentonite were mixed at an aggregate proportion. From the result obtained, the refractoriness of the clay was found to be 1900 C, which qualifies the clay satisfactory in the production of refractory materials. Conclusion. The following can be drawn from the above reviewed. One local clays deposits in different part of Nigeria can serve as a good replacement for imported clays for use in metallurgical and other related areas. This can be achieved by establishing proper scientific records of the clays and comparing them with standards. 2. Refractory clays constitutes certain properties which include moisture content, bulk density, thermal resistance, refractoriness, loss on ignition, plasticity, modulus of rupture and linear shrinkage. These properties have significant effects on performance and durability of the material in metallurgical applications. However, it is very difficult for refractory clays collected from a single site to possess the satisfactory properties required for metallurgical applications. Hence, proper blending of the selected clays with good additives to improve their physical, chemical, and thermal properties is important. 3. The mineralogical and chemical compositions of refractory clays are best examined and evaluated using the following method: X-ray fluorescence, X-ray diffraction, energy dispersive X-ray analysis, electron diffraction, differential thermal analysis, infrared spectroscopy, and electron microscopy. Conflict of interest. On behalf of all authors, the corresponding author states that there is no conflict of interest.